And he will be uh, he will be taking the lab portion, okay, hands-on session. And so reinforcement learning is something that we have done more on textual data as well as numerical data. We have not done much, or rather, we have not done anything on image data. But at the end of this presentation, we'll see how image data is being used in many modern uh, reinforcement learning is used in many modern AI-based image generation, image identification techniques. So we'll have a glimpse of that. And uh, the Python code will allow you to see how reinforcement learning works and how it can be then extended and applied to the image processing domain. Okay, so we'll start with what is reinforcement learning. So reinforcement learning is so this is the typical system for a learning. So that is what we do every day, right? So there is an environment and there is an agent. So agent is so this is basically how humans respond to the stimuli. So that it is based on that mechanism. So typically we are an agent and we have an environment to which we respond. Like if we are coming to college every day, then we know which roads are blocked, which roads are busy, which roads are easy, what time of the day it is easy to travel, right? Or we want to shop clothes, then we know which store to go to, which we like, right? So that's the environment we have. There are n number of clothing stores, but we'll go to few selected ones because we either like their environment, we like their collection, and so on. So there is some reward associated with choosing that action because we know that this is something that is good. Or we go to certain restaurants. There are some and there are thousands of restaurants, but we go to specific ones because we want to reward ourselves with good taste, with good value for money, and so on. So that is the rewards we have. Okay. So that is the rewards we have. Sometimes that restaurant is not serving well. So that's the feedback that we receive. Okay. With that feedback, this agent learns again and it changes its action. Next time we want to go to a restaurant, we'll not go to that restaurant. We'll go to something else. Right. So these feedback mechanisms are inbuilt in this reinforcement learning. And that's why this is also an example of an online learning algorithm. So as the data is coming, as the information is coming, you change the way you behave. Okay, that means you change the way you are taking action. So putting this mathematically is the whole study of reinforcement. So this our common sense thing that how we work, how we decide, how we take action, putting that into a mathematical framework is the notion of reinforcement learning. Obviously, there are many methods of doing reinforcement learning. So there is some theory and then there is implementation. So there are multiple implementations. We are going to see one specific implementation which is called as Q learning. So Q learning is an algorithm which is implementation or instantiation of a reinforcement learning strategy. Okay. So what is reinforcement learning? It has an agent, it has environment, it has a state. State meaning what, where we are, what we are doing. There is a state space in the sense that what are different things that are possible. There is an action that we are going to take, and there is an action space, meaning that what different types of actions that are possible. There is a reward. Reward can be positive or negative. That basically allows you to learn. And then at the end, we have a value or return on doing all the actions or reaching our goal. And that is all decided by a policy. And these all states and actions are put together with a policy. So what action we are going to take at which state is basically policy. Okay. So next. So whenever we do any whenever we do typically a reinforcement learning, we have to take things into consideration of what we have done till now. Okay. But keeping that history is difficult because the more history we keep, the more exponential the state space becomes and more computation is required. So to simplify that, what is done is typically they are assumed to be a Markov decision process. So in Markov decision process, there is no history. So, so for example, here one person who has done PhD and who is currently doing postdoc has come from different, right? But now doing PhD in image processing, postdoc in image processing. But typically, you'll find that people do BTech, MTech, PhD in the same area, right? So, so you see that the history, background, whether that postdoc person is doing a PhD is good enough for us. Okay, so PhD can do a postdoc. We are not going back and trying to figure out what kind of things they are doing. So, depending on how much history you require, your processes change. But to simplify our computation, typically we take history as zero. We say that we are here. Now tell what next to be done. Okay. So that when we convert that to history as zero, we convert that problem into a Markov decision process or Markov decision. So that process is called as Markov decision process, and the problem is called as Markov decision problem. Because in Markov decision, so Markov was a Russian mathematician who studied or built the foundation, the statistics for all such processes which don't have it. So we are taking that, and Markov had done this work in 1920s, so 100 years back. So we are taking this work, and still this is the state of the art. So we are taking this work and converting it into. So that is called as the Markov property. That's zero history. All such processes called as Markov processes, and the reward that we get, the decision we get, these are all basically Markov. So it is basically in the honor of the mathematician Markov. Yeah. Next. So this is the Markov property. So future is independent of the past, given the present. So what we are going to do in future has no bearing on the past. It is just dependent on the present. So that is what the Markov process is. And so the Markov state has a property such that the next state, the probability of going to the next state is depending on the current state. So it is same as whatever states, previous states you must have come, it doesn't matter. What matters is only the current state. The probability of going to the next state, though whatever is the history, is only dependent on the current state. So that is the Markov property. And this is the state transition matrix where now you have current. This matrix basically says that we are in state 1. So this row will define we are in state 1 going to state 1. We are in state 1 going to state 2. So what is the probability of taking that next state is given by this transition matrix. And because in if we are in whatever state, we are going to some state in the next step. So all of these rows should sum to 1. Okay. So so this is the notation that we are going from state S to S dash, where at time t plus 1 state is S dash, and at time t the state is S. Now a Markov process is a tuple where S is a set of states and P is a transition probability matrix. So with this, we define a Markov process. So let's take an example. So an example is like uh, uh, we are, let's say, playing tic-tac-toe. Okay. So there are several states. So each configuration of the tic-tac-toe x0 configuration is the is a state. So if my opponent has played x at the right hand lower corner, okay, what I can play? So right hand lower corner has been taken. There are 8 different positions available to put zero, right? So there are 8 different states I can go to from this state, right? So this becomes the set of states and the probability to choose which one. So I will have some, I have played tic tac toe multiple times. So I know when the right hand side lower has been put, what should I put next? Where I should put a zero. So that is my probability. So I'll put a zero at some point. Most of the time I will put a zero at the same place. But there will be sometimes I would like to experiment. I'll put somewhere else. So you see that. So that becomes the probability. So there is a probability of choosing a state depending on where the first x has been put. So that is one state. We are going to the next state. In the next state, we will have one x and one zero. So there are 8 such possibilities, and there is a probability of choosing that. So this states and the probability transition make a Markov process. Okay, that is the definition of a Markov process. Now we define. So once we play a tic tac toe, then we might win or we might lose. When we win, we try to remember those steps and try to reinforce it, saying that next time if this happens, I will play the same thing. Whereas when we lose, we try to say that okay, this at least try to give lower probability to that. So that is the reward. So this happens intrinsically that like what we happen, we try to do it. No, no, go to step back. So this reward process is like this, and there is one discount factor which is put in. The discount factor is put in so that because we do this multiple times, and if we do this theoretically infinite number of times when we play, so that we refine our knowledge, then if we don't give this future discount factor, so for next plays we'll keep on adding the rewards, and rewards will also go to infinity. So to dampen uh, the amount of rewards that are we are going to play after say 1 million times, 1 trillion times, so that dampening factor is given so that our computation finishes in feasible time, and after a certain moment when the rewards will become insignificant, we'll just stop computation. Okay. So that's why a discount factor is added so that we have a limited number of episodes, a limited number of computations that we need to do. So that is the reward process. And now this is the return. So a return is a total discounted reward from time step t. In the sense that, so what we are saying is that if I am playing a particular thing, particular step, let's say tic tac toe, and I know that this was a winning move, then I would have this much reward. So we let's say quantify reward. If we win, I get 100 points. But if I take this step, I get 20 points because I am already taking a winning move. So I have these rewards for all the steps that are that we are doing, and these are discounted so that the future rewards are. So this is a mathematical framework we are developing. Okay. So uh, Yeah, go back 1 minute. So this is the reward is basically sum of all the future rewards starting from this. Okay, the next. So value function of a Markov reward process is the expected return starting from state S. So if I am in a particular state, what is the expected reward I'm going to get? So that is a basically averaging over a very large sample space. That is what we are talking about. For large sample space, what is the average reward I am will be getting? Okay. So that is defined by VS. Okay. Uh, so so this value function that was VS can be decomposed into two parts. One is बाहेर म्हणजे एकदम बाहेरचं आहे ग्राउंड वरचं. So it can be decomposed into two parts. That is, one part is the immediate reward, that is for that state, and the discounted rewards for the next state that we are going to get. So if you see that we take Vs as expected value of Gt given the starting state as S, where this is the immediate reward and then discounted reward for further states. Now this discounted rewards, if we basically take this uh, gamma as common, then we see that this discounted reward actually is starting from state S plus 1. We can basically do a short form of this, that expected reward of Vs is nothing but the immediate reward plus gamma times the reward from the next state. Okay, so let's go back all the slides and let's see all of these things. So this is the our model of reinforcement learning. Next, next, next. So this is the probability. This is the Markov property, that the probability only depends on the current state. Then this is a state transition matrix. Okay. So this is like current state going to the next state. Next. This is the Markov process, which have set of states and the transition probability matrix. Then we have a reward function and a discounted factor so that we don't get into infinite rewards. Now we are playing with rewards. We are trying to see how much is the maximum reward uh, return that a Markov process can give. So this is that. Next. So we are now saying that this maximum return for a particular state. So that is V given by Vs. That is the expected value of this reward starting at state S as at the current point of time, which is same as next expected value of the current reward plus discounted reward for the from the next. Okay, we are till here. Okay. So now this Markov decision process is now given by this tuple, the set of states, the set of actions that we can do, the state probability matrix, the reward function given at the state S and the action we do, and the discount factor. So this defines the Markov decision process. Okay. So till now everyone with me, right? Okay, next. So now the new definition is the policy. So policy says that what action I'm going to take for a particular state. So it's basically the probability of that particular action for that state. So currently, till now we had going from state to state. Now when we are going from state to state, we also take one action, right? So we are so like when we are playing tic tac toe, We are going from one state to the next state, where in first state we had one x, in the next state we had one x and one zero, but we are taking an action of putting a zero in a particular box. Okay, so this is the probability of putting that zero. Okay, so okay, so for example, other thing can be like, uh, today it is not raining, tomorrow it might be raining, so we might go from not raining to raining state. Okay, and the action can be very different. So action can be like, I carry umbrella with me or not. Okay, so this is the probability of that action given today's condition, right? So so a policy defines the behavior of the agent. So it defines what action it is going to take next, and it also defines which state it is going to go next. Again, the policy and action only depend on the current state. Okay. So the state value function, we talked only about the expected value of the rewards given the state. Okay. Whereas the action value function will also have uh, state and the action. Okay, so now we will have two tables, one which is from state to state and another state to action. So in what state we are going to take what action, and from that, after that taking that action, in which state we are going to go. So the value function of S for state we have already seen is the expected value of the current rewards plus gamma times discounted value of the reward from the next state. Similarly, we can have uh, state action, uh, state action uh, function, which states that expected value of the current reward plus gamma times this, gamma times the uh, same. So we see that there is this, like, we have this V, we have this Q. So state action for the next step. Okay. So from here, when we have defined these two policies, we can have the optimal policy. And optimal policy is basically nothing but first finding out what is the optimal function for V and Q. And what is the optimal function of V and Q is basically, go back to that state transition matrix. So once we have calculated this, the optimum value of P would be whatever is the highest here. That is the optimal probability of the next state. Right? So the optimal probability, optimal value is nothing but it's nothing but whatever is the maximum value in that row. Okay. So similarly, the optimum value of state action is the maximum action value over all policy. Right. So go back. So the optimal value function specifies the best possible performance in the NDP, and the MDP Markov decision process is solved when we know the optimal value. Okay, so this is our assumption. Based on this assumption, we are trying to solve this. Whether this works in real life or not, we don't know, because you see, regression or any other machine learning technique, they have their own assumption. They find their own function which is optimal in their own way. So this is also an assumption, and based on this assumption, which mostly because we are mimicking the human processes, natural processes, this works mostly uh, in a very good way. But obviously, we need to study the data on which we are working on. We need to study the problem and then apply different machine learning techniques. For many of the techniques, this works very well, especially the techniques which are human generated or human actions are there. Okay. And that's why we worked on this. We tried to work on the stock market data, where there is a lot of human action involved. The stocks move because there is someone who is buying or selling. And once that action is done, then only the stock will move. Otherwise, if there is no buying or selling, the stock will remain stagnant. Right? That price will not move. So Jagdish PhD thesis was actually using reinforcement learning, applying it to the stock market data, and we got very good results. We got many publications out of that. Okay, so so there can be many policies. Okay, and how we define the policy is basically now we are trying to find the policy, right? So we want to try to find the two matrices. One is the state transition matrix and state action transition matrix. So uh, now mathematically we want to define if there are multiple number of these matrices given, which matrix is the best, which matrix is the optimal. So we are trying to define that, and then once we define that, we will have a mathematical model of achieving that. So given any policy, that is any state transition matrix or any state action matrix, we define that if uh, this for every pi s vs is greater than v dash s for all s, then we say that we can this policy is better than the earlier policy. And we say that so we don't prove, this was proven by Markov, that there exists an optimal policy that is better or equal to all other policies. So given, so we want to find this policy which is optimal, which is better than all other policies, which will give us the best rewards. So we want to optimize the rewards. Next. So the rewards can be like in terms of stock market, the reward was the amount of profit that we are going to make. But in terms of tic tac toe, it can be the number of times we win the game. So reward definition can change with the problem. So this Q learning algorithm, this is a very specific instance, as I told you, of solving a reinforcement learning problem. So reinforcement learning, we are having, we are trying to make, we are trying to find the optimal policy. And our assumption is that once we find that optimal policy, we'll solve all the problems in the world. Okay, so this is the best policy possible. So this is one technique of finding. There are multiple techniques. This is one technique of finding the Q learning algorithm, and this uh, code, like this library, is available in Python. So so Q learning algorithm is basically a reinforced learning technique, and it has its own Q table. Okay. So this Q table is basically state. So a state action table is called as Q table here, and so as we have seen that the rewards. So what it does is that this Q table is populated by not looking at the states now, by just looking at the rewards that we are going to get. So here it says that whatever state we are in, what is the maximum rewards I can get in the next step? What is the maximum rewards I'm going to get in the next step, and so on. So basically, like we had modeled our state function, we are modeling our reward function also on future projected rewards, which we have not seen yet. Okay. So if we basically model like this, our reward function, it looks like RT is equal to sigma equals to 0 to infinity gamma rs to k r t plus. Right. So this is basically short form of this. And now this Q table is populated the estimated rewards that we are going to get given state S and doing action A. And Q function is basically the maximum Q rewards that we can get. So it is modeled exactly on the similar lines, but now we are focusing only on rewards. We are not focusing on the state. Okay. So again, it is Q star SA is given by the same equation. So if we simplify this, what we get is Q of Q value of the state and action is equal to whatever it was. So this is the next iteration. So we are doing computing using multiple iterations. So in the first iteration we had all zeros, like go back. So this Q table was all zeros. In the next iteration we update it saying that whatever was the earlier value plus the current reward into the next possible rewards minus the so that we are adjusting it so that we don't get infinite rewards. So this alpha is the new thing that has been introduced, and alpha is the learning rate. The higher alpha we have, the the higher alpha we have, we will basically very quickly converge, but mostly will converge at a local maximum. The lower alpha we have will require more iterations to converge, but we will converge most probably in the global maximum. Okay, so this is an approximation. Okay, so what we are saying is that we'll approximate this iterative approximations will do. We'll compute the Q values again and again, and this will give us most probably the best way to choose given a state, choose the next state, given a state, choose the next action. So, madam, this will share. Can I? Yeah. So, okay. So this alpha basically defines what is called as the exploration versus exploitation. So this is a typical theme in any AI technique is that uh, exploration is finding out new things and exploitation is doing the same thing again and again. When you do the same thing again and again, you become expert in that and you dive deep into that. Right? Whereas when you explore, you reach the more depth. So depending on how much exploration and how much exploitation you do, your algorithm. So that alpha is basically uh, doing the choice between how much exploration should be done and how much exploitation should be done. So meaning that if you have a lower alpha, that means that you are doing more exploitation. Sorry, exploration. And when you have a higher alpha, that is the other way around. Okay. So it's like again coming from our day-to-day experiences. If you are taking, say, let's say microprocessor, 5 years, 7 years, 10 years, 15 years, you will discover so many small things that you become expert. You are exploiting that. But if you basically teach every semester you teach a different subject, you will have a very broad view of that field. But intricacies, insights, you will not be able to develop. You have to have a balance. So that is basically that alpha is doing. So we do this in day-to-day life. So these are all things in reinforcement learning. This is a new technique It is not supervised learning or unsupervised learning. This is a different technique where we are trying to mimic how humans behave. So next. So this is the Q learning algorithm. So we initialize the QSA, that is the and that can be arbitrary, and it can be all initialized to zero. So we can have all initialization. Typically, you'll see all examples. This is initialized to zero, and then we have each episode. Episode means that uh, we have one step taken step from starting to the goal, and in the goal we might be rewarded positively or negatively. So each episode you can consider a game of tic tac toe. So you play the game, you go from one step to another, and then either you win or lose or draw. So let's say if you win, you plus 100, if you lose minus 100, and draw say minus 50 because you don't want draw. Right? So you can give like that, and so you repeat. So each step in the episode, you choose a policy, and you take that action defined by the policy. Once that action is taken, you update the Q table. Okay, you update the Q table, and then you update the you go to the next step. So you have taken a step, you go to the next step, and you keep on doing this again and again and again, thousand times, million times, and so on. And then your table will stabilize. And that table, where going from state to state, going from state to action, will give us what what is the most optimal strategy to be followed. Okay. Again, I'm telling you this is an approximation. So the first approximation is that there is no history. So we are actually discounting a lot of things. The second approximation is that we are able to find an optimal policy which is the best policy. The third approximation is that Q table is the best way to find that optimal policy. Okay, and the fourth approximation is that this Q table can be found out using iteration. Right? So all of these are approximations, and each approximation adds its own errors in this value. So this may not be optimal for many of the things. But what we have found is that this works very well when human or human generated things are involved. And we'll see the example of this at the end. So first we'll understand next. So I'll hand it over to Jagdish for, so whatever we have done, we'll do it in Python, and then I'll come back and we'll talk about the example. सरांना पाठवून द्या ना. सर पाठवले. So Jagdish is sharing a Google Colab link so that you can have a look at the code, and you can execute as well. काय झालं का काम? अरे का बरं? अच्छा, आले का पण ते? नाही नाही, माझं झालं एक तास जवळपास 10 ते 11. आता हा लॅब घेतोय जगदीश. हा, तो आता 11:30 पावणे 12 पर्यंत घेईल, मग टेक ओव्हर करेल. हा, मग 12 पर्यंत आहे ना जवळपास. हम्म. ठीक आहे. कितीपर्यंत वेळ लागेल तर मग? हा, नाही मग समजा जर मी उचलला नाही तर मग समजून घ्या चालेल. हम्म. हॅलो रमेश. ठीक आहे ना, काही हरकत नाही. मोबाईलवर चालून जाईल. हा, तुम्ही दाखवून द्या ना जगदीश. एक दाखवून द्या, मग आपण हे करता येईल. दॅट्स ओके. ते राहूच द्या. हा, ते बेटर. Yes, Jagdish, I think you can start.
Suppose this is a house containing what we can say 9 rooms, okay, and we put a robot inside any room, and we have to navigate that robot to the room number 8. Suppose this is a goal state, okay. Robot can be in any state, so he has to find out the what we can say optimal path from any state to goal state, okay. So in this case, this every room is a state. We can use any representation to represent the what we can say state and state space. So in this example, I have considered state space. So there are total 9 states. So number of states are 9. Okay, and I have numbered this from 0, 1, 2, 3 up to 8. So total states are 9. So this is our state space. Similarly, a robot. So this is about the state and state space. Okay. Another important concept in reinforcement learning is action. So what action a agent can take. Okay. So in this case, if there is a robot, okay, so he can move left, he can move right, up or down. So suppose there are only 4 actions possible: left, right, and up, down. So our action space will be 4. So एक बार मैं एक्सप्लेन करता हूँ, उसके बाद जो लिंक शेयर की है आपसे करना एक बार आप देखिए. So I am importing the NumPy library that is required for data manipulation.
मोबाईल वरनं करा ना.
Okay. So I have imported the NumPy library. Okay. So now I will take the two variables. First is number of states. So in this example, there are total 9 rooms. So number of states equal to 9. Then number of actions. So our action is 4. So number of action are 4. Then as sir discussed, the agent try to learn the policy. So given a state, what action he will take. So in Q learning, that policy is represented using a table. So this is a table. Means here there are states. State 1, state 2, state 3, up to state number 8. We have state from 0 to 8. So these are the 9 states. Then action 1, action 2, action 3, and action 4. So these are the actions. So this is a Q table. So initially all the values are what we can say random, or it can be 0. So initially in this Q table, I have taken all the values 0. Now we will apply Q learning algorithm to find out the optimal policy. So after applying the Q learning algorithm, you will find out the optimal policy. So what will be the optimal policy? The meaning of optimal policy here is given a state 0, which action we have to take. So here 1, 2, 3, 4, there will be Q value. Suppose this is the state S1. Okay. So for this state you will have 4 values that is belonging to different We have different into three grid world. We can define four into four also, no, depending upon the state. Depending upon the state, that can be varying. It's not mandatory that we need to take three into three also. Yes. And according to them, then Q will be varying, no, sir? Yes. So in this example, there are nine rules. So nine states and action are four. So for a state, if the agent is in a state, so four action are possible. So in this Q table, there will be four Q values. So agent will take action whose Q value is more. If the Q value of action number two is more, then it will take action number two. So we have to find out this table. So that will be done by what we can say Q learning algorithm. So internally that Q learning algorithm uses Bellman equations for updating this value. So I hope कि यहाँ तक समझ में आ गया. This is our policy. That is Q table initiality zero. So now this is reward function. So based on a problem, एक तो we will learn the reward or we can directly provide the reward. तो जैसा आपका प्रॉब्लम स्टेटमेंट होगा अकॉर्डिंगली आपको रिवॉर्ड फंक्शन लिखना पड़ेगा. तो वी कैन से रिवॉर्ड फंक्शन इज अ हाइपर पैरामीटर, मतलब वो लर्न नहीं करते, वो प्रोवाइड करता है. तो यहाँ पे रिवॉर्ड फंक्शन क्या है देखिए. इफ एजेंट इन द रूम जीरो, ठीक है, तो अगर वो लेफ्ट साइड में जाता है तो ये पॉसिबल नहीं है, वो घर से बाहर निकल जाएगा. अगर अब जाता है तो भी पॉसिबल नहीं है. क्या एक्शन पॉसिबल है? You can go right and down. So चार ही एक्शन है. तो फर्स्ट इज नॉट पॉसिबल, सेकंड एक्शन इज नॉट पॉसिबल, थर्ड एक्शन इज पॉसिबल है, फोर्थ एक्शन इज पॉसिबल. तो यहाँ पे क्या करेंगे, जो इनवॉलिड एक्शन है जो पॉसिबल नहीं है, वी विल रिप्रेजेंट दैट यूजिंग -1. ठीक है. तो जो एक्शन पॉसिबल है उसको मतलब जो एक्शन पॉसिबल नहीं उसको -1 रिवॉर्ड देंगे, जो पॉसिबल है उसको 0 रिवॉर्ड देंगे. सिमिलरली ये गोल स्टेट है. तो गोल स्टेट अगर आप स्टेट नंबर 5 में हो, स्टेट नंबर 5 में हो और आप डाउन एक्शन परफॉर्म करते हो, तो यू विल बी इन अ गोल स्टेट. इसके लिए जो रिवॉर्ड है दैट विल गिव डिफरेंट. इन दिस केस यू विल गिव 100. सिमिलरली 7 से, तो अगर आप 7 में हो और आप राइट एक्शन परफॉर्म करते हो, राइट डायरेक्शन में मूव करते हो, तो आप गोल स्टेट में पहुंच जाओगे. तो उसके लिए 100. तो ये दो केस के लिए 100, बाकी सभी केस के लिए 0 है, -1. तो ये जो नंबर है ये आप पे डिपेंड है, आप अकॉर्डिंगली नंबर दे. तो दैट इज रिवॉर्ड फंक्शन. तो रिवॉर्ड फंक्शन आपको ही देना पड़ता है. स्टेट नंबर 8. तो इन स्टेट नंबर 8 वी आर डन, मतलब गोल स्टेट में पहुंच गए, वहां से कहीं जाना नहीं है. ठीक है. तो इस स्टेट के लिए मैंने यहाँ पे -1 लिखा है, मतलब इनवैलिड. एक बार गोल स्टेट में पहुंच गए तो कोई भी एक्शन, हाँ, तो आप कैसे कोड लिखते हो उससे बेस है. तो अगर आपका प्रॉब्लम ऐसा है कि एक बार वो स्टेटमेंट चले गए तो बाहर नहीं जाना, तो यहाँ पे भी एक बार फुल स्टेट मिल गया तो बाहर नहीं जाना है, तो इसलिए आप मैंने इनवैलिड मतलब कोई भी एक्शन परफॉर्म करेंगे तो वही स्टेट बनेगी, बाहर नहीं जाएगी. तो ये रिवॉर्ड फंक्शन है बेस्ड ऑन प्रॉब्लम, ये आप स्ट्रक्चर करोगे. तो आई होप ये आपको समझ में आ गया. ये स्टेट जीरो है, तो लेफ्ट साइड और अप साइड नहीं जा सकते इसलिए -1, राइट में और डाउन में जा सकते इसलिए 1. अकॉर्डिंगली सारा आपको दो बार 100 दिखे, जीरो मतलब वैलिड है, ठीक है, उसका रिवॉर्ड अपन जीरो देंगे। और 100 का मतलब है गोल स्टेट में जा रहे हैं तो ज्यादा रिवॉर्ड देंगे, तो 100 की जगह आप 2 भी लिख सकते हैं, और फिर डिफरेंट डिफरेंट होना चाहिए। सिमिलरली सर बघा ते वरचं मॅट्रिक्स बघा सर की वरचं मॅट्रिक्स वरच्या मॅट्रिक्स मध्ये सर 0 1 2 3 4 5 दिलेले आहेत सर, आता 6 7 8 आता आपल्याला माहित कसं पडेल की सर 0 मध्ये आपल्याला ही स्टेट तुम्ही याच्याबद्दल बोलताय त्याच्यावरती मॅट्रिक्स बनवला ना त्याच्या अजून वरती हो हाँ हाँ आता हा 0 पासून 1 मध्ये हे मॅट्रिक्स नाहीये, these are the what we can say rooms, and there are numbers here, room 0, room 1, according. Similarly, in MDT there was a component that is state transition practice. तो ये जो प्रॉब्लम है इसमें जो स्टेट है, ठीक है, तो दिस इज स्टेट ट्रांजिशन, so these are the state 0 1 2 3 of the state and these are the action. So if you are in the state 0, आप वहां पे देखिए, अगर आप स्टेट 0 पे हो तो एक्शन 1 परफॉर्म, एक्शन 1 का मतलब है these are action, action 0 1 2 and 3. So if you are in a state 0 तो action 0 अप्लाई करोगे तो you will be in a which state, इनवैलिड स्टेट है, तो आप वही में होंगे, इसलिए 0 से 0 में ही होंगे। सिमिलरली आप एक्शन 1 परफॉर्म करोगे, आप थर्ड जाओगे तो वही रहोगे। इफ यू परफॉर्म एक्शन 2 मतलब आप राइट साइड में जा रहे हो तो कौन से रूम में जाओगे आप, 0 से 1, तो दैट्स व्हाई आई हैव रिटन हियर 1। सिमिलरली अगर आप थर्ड एक्शन परफॉर्म करोगे तो यू विल बी इन स्टेट 3, तो उसके लिए 3 अकॉर्डिंगली सारा लिखा है। तो लास्ट स्टेट का चेक करते हैं, फॉर एग्जांपल अगर आप स्टेट नंबर 8 में हो और आप 0 परफॉर्म करते हो तो आप 7 में आ जाओगे, अगर आप अपवर्ड जाओगे तो आप 5 में आ जाओगे, डाउनवर्ड जाओगे इनवैलिड मूव है वही रहोगे, ठीक है, उसके बाद राइट में जाते हो तो वो भी इनवैलिड है, आप वही रहोगे। तो ये ट्रांजिशन मैट्रिक्स है, ये भी हाइपर पैरामीटर है, ये आपको प्रोवाइड करना पड़ेगा ये समझना प्रॉब्लम। तो ये लर्न नहीं करना है, लर्न बस क्यू टेबल लर्न करना है। सिमिलरली जो सर ने एक्सप्लेन किया था बेलमैन इक्वेशन, तो ये जो अपडेशन होता है तो इट इज इटरेटिव प्रोसेस, तो नंबर ऑफ एपिसोड है यहाँ पे 5000 है, तो एक एपिसोड पे क्या होगा, जो क्यू वैल्यू है दैट विल बी अपडेटेड। एपिसोड का मतलब है कि स्टार्टिंग फ्रॉम इनिशियल स्टेट टू गोल स्टेट, जो एजेंट है वो ट्रैवल करेगा इनिशियल स्टेट टू गोल स्टेट के बीच, ये एंटायर एपिसोड होगा। ड्यूरिंग दैट एपिसोड ही विल टेक डिफरेंट डिफरेंट एक्शन, तो हर टाइम क्यू वैल्यू अपडेट हो जाएगी। वो क्या आपको समझ में आ रहा है, पिछला you will get replaced every time. टेबल में थोड़ा सा जी जी। एपिसोड का मतलब क्या है कि अगर ये स्टेट में है, इसमें से एक एक्शन परफॉर्म हुई, सपोज वो इस स्टेट में आ गया, फिर से उस स्टेट में चला गया, एक स्टेट में एक्शन लेंगे, नेक्स्ट स्टेट में लेंगे, ऐसे चलते रहेगा। इवेंचुअली वो कभी ना कभी गोल स्टेट में पहुंच जाएगा। वो हो गया एक एपिसोड। मतलब ठीक है। इसके बाद क्या इनके बीच में सपोज वो एक पर्टिकुलर स्टेट में है, ठीक है, और बेस्ड ऑन वो पॉलिसी एक्शन डिसाइड जो क्यू टेबल है, अगर मैं इस स्टेट में हूँ तो कौन से एक्शन परफॉर्म करनी है, दैट विल बी डिसाइडेड बाय पॉलिसी। पॉलिसी का मतलब क्यू टेबल। तो इनिशियली तो क्यू टेबल में क्या है, सब रैंडमली है, मतलब इनिशियली क्यू टेबल में सारी जीरो है, ठीक है। तो इनिशियली वो टेबल वो क्या हो गया, एक्सप्लोरेशन। तो इनिशियली एक्सप्लोरेशन कम करते हैं इनिशियली कोई, अगर वो टेबल से ही अगर डिसाइड करते हैं कि एक्शन कौन सी लेते, दैट विल बी एक्सप्लॉइटेशन। इनिशियली एक्सप्लॉइटेशन नहीं करते, इनिशियली एक्सप्लोर करते हैं। तो इनिशियली रैंडमली डिसाइड करते हैं कि अगर ये स्टेट है तो रैंडमली विल क्रिएट द एक्शन। तो एक स्टेट है और आपने एक्शन डिसाइड कर लिया, तो उससे क्या होगा, यू विल गेट रिवॉर्ड। आपको कुछ ना कुछ क्या मिलेगा, रिवॉर्ड मिलेगा। तो और आपको नेक्स्ट स्टेट मिलेगी। एक स्टेट है, आपने एक्शन ली, तो आपको क्या मिल सकता है, रिवॉर्ड मिलेगा, नेक्स्ट स्टेट मिलेगी। तो ये इक्वेशन के सारे पैरामीटर मिल जाएंगे। तो वो जो स्टेट और एक्शन की जो की वैल्यू है वो चेंज हो जाएंगे बाय यूजिंग दिस इक्वेशन। तो वो जीरो था तो उसमें कुछ चेंज आ जाएगा, ठीक है। इफ द न्यू एक्शन तो उसकी की वैल्यू ये इक्वेशन से चेंज होगी, ये बेलमन इक्वेशन। तो ये की वैल्यू चेंज होने के लिए आपको रिवॉर्ड चाहिए, इमीडिएट रिवॉर्ड, और नेक्स्ट स्टेट चाहिए। तो इससे वो की वैल्यू मिलती जाएगी और की वैल्यू अपडेट होती जाएगी।
Should we do that example? ते करायचं का एकदा? ते कसं होतं मग कॅल्क्युलेशन एक स्टेप,
एक
ती एक्झाम्पल घ्या ना. एक काम करा. हा, हे क्रॉस करून द्या. हे क्रॉस करून. आणि हा आहे ना, मध्ये मध्ये घ्या मध्ये. अजून मोठा करा ना. नाही पहिले ते दाखवा ना चित्र. मोठा करा, मोठं मोठं करा. राईट हँड साईड अजून मोठा करा. So so this is a start and this is the finish. Okay. So these are all five rooms, one, two, three, four, five. And there is, so from two you can't go to four directly. You can go to three. So from room two you can only go to three. From three you can go back to. So, so currently this is the start and this is the goal. That is the room number five. And there are only these things you can go. So the reward function is that when you reach this five, it is 100 and all others are 0. And then from room 2 you can't go to room 1 directly, so you have a negative reward function there. So you can go down to now we can explain.
ये तो मैंने एग्जांपल दिया है और ये थोड़ा उसमें डिफरेंस है। इसमें ये अजूम किया है कि हर रूम के बीच में अगर इफ दे आर नेबर तो उनके बीच में डोर है, ये वहां का अजम्पशन है। यहाँ पे ऐसा नहीं है, रूम जीरो और रूम वन के बीच में डोर नहीं है, इस पर। तो ये जो आपको डायग्राम दिख रही है यही स्टेट ट्रांजिशन है। तो यही व्हाट वी कैन से रिवॉर्ड फंक्शन। अगर ये जो नंबर है लेबल है वो हटा देते तो ये ट्रांजिशन है, अगर वो रखते हैं तो दैट विल बी रिवॉर्ड।
So this is the initial setting and then we need to calculate. So
दिस इज रिवॉर्ड मैट्रिक्स, दिस इज इनिशियल टू टेबल, ये लर्न करना।
So go up, go up. Huh. So here we can go to step 5 from room number 1, 4 or 5. That's why these reward functions are 100. All others where we can not go to is 0 and where we can't go is minus 1. So we are going from 1 to 5. So
So in that example, agent in the current state one, and he is taking action three. तो उसका वो रिवॉर्ड है दैट इज जीरो. Suppose agent state one में and he is taking action five for example. तो उसको क्या मिलेगा? He will get reward. Okay, plus next state. तो वेरिएबल इक्वेशन याद कीजिए. वेरिएबल इक्वेशन क्या होता है? मतलब current state, current action, value of current state and current action equal to reward plus discounted value of next state and next action. So this is what we can say immediate or current reward plus ये point at ये learning rate. Okay, so discounted values of
max of these things. So max of these values. 5 can we can go from 5 to 1 or 5 to 4 or 5 to 5. So currently everything else is 0 for this. So this max value will be 0. Maximum can be 100. हाँ so
ये reward.
नहीं ऊपर maximum can be 100 or 0. No हाँ so this is reward, this is Q value. These are these two different tables. So initially the Q table are all zero. So the reward for 1 to 5 is 100.
तो ये कंप्यूटेशन आ रहा 100 इसको मल्टीप्लाई करके लर्निंग रेट से और उसको सब्सट्रैक्ट करेंगे ओल्ड क्यू वैल्यू से. तो आप इतना समझिए कि ये जो क्यू वैल्यू है दैट इज गोइंग टू बी अपडेटेड. पहले जो थी वो नहीं लेंगे. It can be any. It can be any real value. Arbitrary can be zero. Any number can be zero. जो रिवॉर्ड दे रहे हैं
ये तो एक स्टेप हो गया सर. हाँ एक स्टेप हो गया. ऐसे बहुत सारे स्टेप्स लेके एक एपिसोड होगा और ऐसे एक एपिसोड मतलब एक गेम और एक ये
जो रिवॉर्ड है उसको चेंज नहीं.
और ऐसे बहुत सारे गेम्स खेलने. उसके बाद
वैल्यू अपने ऊपर है रखना जो भी रखना है.
हाँ हाँ यस
दो रख सकते हैं, पांच रख सकते हैं.
एनी वैल्यू.
तो रिवॉर्ड का जो टेबल है वो एलजीडी टेबल तो आपको चेंज नहीं करेंगे. तो इनिशियली क्या थी ये जो Q1,5 है इसकी जो Q वैल्यू थी वो जीरो थी इनिशियली. लेकिन ये कंप्यूटेशन करने से क्या हुआ उसकी वैल्यू चेंज हो गई बिकॉज ऑफ ये रिवॉर्ड जीरो नहीं है. अगर रिवॉर्ड जीरो होता तो वो अपडेट होकर जीरो ही होती. तो इनिशियली क्या है वो सारा ही जीरो रहता है तो अपन क्या करते हैं रैंडमली एक्शन देते हैं और बेस्ड ऑन दैट वो की वैल्यू चेंज होती रहेगी. तो जैसे जैसे एपिसोड आगे आगे बढ़ते हैं जो मतलब जो और एप्सिलॉन जो था वो धीरे धीरे बढ़ते जाता है. अगर एप्सिलॉन 1 है तो फिर एक्सप्लोर नहीं करते एक्सप्लोर करते हैं. तो ये जो की वैल्यू है अभी ये चेंज हो गई है. इनिशियली सारा जीरो जीरो था अभी यहाँ पे 80 यहाँ पे 100. तो इवेंचुअली यहाँ पे जो मेरा कोड है उसमें 5,000 एपिसोड होने वाले. तो उसमें एक स्टेट और एक्शन जो पेड़ है वो बार बार आती रहेगी. तो जो
इसमें थोड़ा ऊपर जा. गो. हाँ तो यहाँ पे गो अप गो. वन वन स्लो स्लो स्लो. This was episode 1 where we got 100. Now we are doing one episode 2. थोड़ा स्लो जाओ ऊपर. थोड़ा 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 सा ऊपर. ओके. यहाँ यहाँ पे कौन नहीं. हाँ ये पढ़ने दो. Selected we on this new state we selected room 3 and from 3 we have to choose one action. Go down. So from 3 we have to choose one action. There are 3 actions that are possible with 0. So randomly we are choosing one. So we are choosing one of them. So let's the action chosen is 1. थोड़ा धीरे धीरे जाओ. Yeah. By selecting action 1 as the next state, we have the following possible actions. धीरे धीरे जाओ. So one say we can have this and this. So here clearly we are going to choose this, right? So now our episode is 3 to 1, 1 to 5. Okay. So now 3 to 1 is हमको calculate करना है. So 3 to 1 is what? 3 to 1 plus 0.5 into max. The next state can go to 1 to 3 or 1 to 5. So here 1 to 5 was 100 and our this learning rate is 0.8. So 3 to 1 reward from 3 to 1 is 0, but उसका Q table already was updated. So now the next Q table for 3 to 1 will be updated. So now there will be two values in Q table. One is 100, another is 80. 100 and 80. So इस तरह से वो update होते जाएगा. So this will happen for the next episode. Here we are going from 3 to 1 and 1 to 5. Then we will have another episodes and we will have multiple such episodes, multiple such gameplay, and we will update it.
सर ये बोला कि लास्ट में ऑप्टिमल पॉलिसी चाहिए. ऑप्टिमल पॉलिसी मतलब ये ऑप्टिमल टेबल कि अगर ये स्टेट में है तो कौन से एक्शन लेंगे हैज टू बी डिसाइडेड बाय दीस वैल्यू. तो यहाँ पे कौन सी वैल्यू, यहाँ पे कौन सी रहेंगी, ये ऑप्टिमल वैल्यू चाहिए तो एट द एंड ऑफ दिस.
So this optimal value can be divided in two ways. So we can have the number of episodes. बोलेंगे कि 1 million episodes के बाद will stop. Or we can say that कि from this matrix to this matrix, in consecutive 3 or 4 matrices we are not seeing any change, will stop. यानी 3-4 episode के बाद भी कोई matrix change नहीं हो रहा है तो will stop. So stopping can be based on threshold or it can be based on the number of episodes. Yes. तो जितना डिस्काउंट फैक्टर कम रहेगा उतना ज्यादा टाइम लगेगा. No. So it is depends on your experience. No, no, it is based on your experience and trial and error. So it depends on the problem.
They are hyperparameters that will be decided by what the distance.
One and minimum close to zero. Close to zero. Zero to one. नहीं, you go down. No, so go down. Show the last matrix after. Yeah. So go slightly up. So this is the Q matrix after many iterations. So this is stabilized here. तो इस तरह से वो चेंज होते रहेगा depending on your. So now if you are in state 3, then you can choose go to either 4 or 1, and once you go to 4 you have to, so you always pick the highest one. Go to 5, or if you go to 1 also you can go to 5. So you start from any, let's say if you start from 0, from 0 you go to 4, then from 4 you go to 5. So the highest in the row will tell you which action to take. And depending on the action, the state will also change.
So this is learning rate and this is discount factor. So discount factor, so value is 0.95, but it is up to you. Based on your experience, you can decide from zero to one. Everyone is one. So again, this is our initial Q table. Everything is zero. Okay. Then we have decided reward function and what we can say transition function. So now I have written that Q learning algorithm in Python. and it is basically based on these lines, and that is Bell equation. ये जो Q वैल्यू है, Q स्टेट एक्शन ये अपडेट हुई है बाय यूजिंग दैट। तो जो करंट वैल्यू है और आपको नेक्स्ट व्हाट वी कैन से एक ओल्ड क्यू वैल्यू है, एक नेक्स्ट क्यू वैल्यू मिलेगी। तो जो नेक्स्ट क्यू वैल्यू है उसको मल्टीप्लाई करेंगे लर्निंग रेट से, फिर दोनों को सब्ट्रैक्ट करेंगे और वो जो डिफरेंस है वो उसमें ऐड करेंगे जो ओल्ड क्यू वैल्यू है। तो ये लॉजिक से क्यू वैल्यू चेंज होती जाएगी। तो अगर एक एक्शन परफॉर्म किया आपने और एक्शन प्रॉपर नहीं है तो आपको जो रिवॉर्ड मिलेगा दैट विल बी निगेटिव, तो उससे क्यू वैल्यू कम हो जाएगी। अगर आपने एक्शन जो परफॉर्म की वो अप्रोप्रिएट है तो आपको पॉजिटिव रिवॉर्ड मिलेगा। तो वो जो क्यू वैल्यू है दैट विल बी इंक्रीज। तो क्यू वैल्यू की इंक्रीज और डिक्रीज बेस्ड ऑन टाइप्स ऑफ रिवॉर्ड, पॉजिटिव और नेगेटिव। तो एक्शन अगर नेगेटिव है तो नेगेटिव रिवॉर्ड देगा, उससे माइनस
हाँ रहा नहीं करेक्ट। अच्छा अच्छा नाही माझा प्रेझेंट आहे ते वर्कशॉप आहे PA मध्ये इकडे आला अंशुल असेल
जैसे बाकी मशीन लर्निंग के एल्गोरिदम होते हैं जहाँ पर डिसीजन ट्री या न्यूरल नेटवर्क, तो उससे लाइब्रेरी अवेलेबल होती है, लेकिन इसकी नहीं रह सकती क्योंकि बेस्ड ऑन जो आपका प्रॉब्लम है अकॉर्डिंगली आप स्टेट को रिप्रेजेंट करोगे, अकॉर्डिंगली आप एक्शन को रिप्रेजेंट करोगे, तो मोस्टली यहाँ पे हार्ड कोड ही करना है। कॉन्वर्जेंट होना चाहिए, मतलब जो ऑप्टिमल रैंडमली चूज नहीं कर रहा है, मतलब जनरली सबने जैसे बोला कि दो टाइप है। एक होता है कॉन्वर्जेंट, कॉन्वर्जेंट मतलब ये इक्वेशन और उसके बाद वाला इक्वेशन उसको टेबल में कोई चेंज नहीं आ रहा है। अभी क्योंकि टेबल में कोई चेंज नहीं आ रहा है तो वहाँ पे रिजेक्ट। हाँ, दूसरा ये ट्राई एंड नंबर ऑफ एपिसोड में इनिशियल स्टेट टू गोल स्टेट जो हम वन रूम एंड ऑल एक्शन।
नो नो नहीं एपिसोड बेसिकली सेज दैट कि जैसे ये गोल स्टेट है सो फ्रॉम 1 आई गो टू 4 3 6 7 4 5 ये एक एपिसोड हो गया मतलब आई कैन I am going from different. So what I am trying to do is that I am generating. So in a sense that uh, in a real life, how the agent has done. So the agent has done this way. So this is one episode where it starts from some place and it reaches the goal state. ये गोल स्टेट पॉजिटिव ही है देर माइट बी अ बैड स्टेट ऑल्सो हो सकता है कि एजेंट जाके वहां लग जाए so it might have negative rewards.
और ये पॉसिबल है,
हाँ
ये पॉसिबल है उस केस में 100 में भी वही है। हाँ, ये होगा लेकिन एक बार वो टेबल अपडेट हो गया तो फिर इसमें एपिसोड रन नहीं करते, तो करंट जो एक्शन अप्लाई करेंगे वही चेंज होता है। तो ये तो ट्रेनिंग पर्पज के लिए ये सब, एक बार ऑप्टिमल टेबल मिल गया इसमें एपिसोड नहीं करना। तो ये क्यू लर्निंग एल्गोरिदम ही है जो पाइथन में है, मैं हाई लेवल का यहाँ पे एक्सप्लेन करता हूँ। तो ये जो लूप है दिस इज फॉर नंबर ऑफ एपिसोड। उसके बाद एक एपिसोड से क्या होगा, तो फ्रॉम इनिशियल स्टेट वी विल गो टू गोल स्टेट। तो ये एपिसोड एंड कब होगा, व्हेन यू विल रीच टू स्टेट नंबर 8। स्टेट नंबर 8 इज योर गोल स्टेट। तो फ्रॉम एनी स्टेट ये लूप रुकेगा कब जब गोल स्टेट में पहुंच जाएंगे। इन बिटवीन क्या होने वाला है, तो वी हैव स्टेट, तो अपने को एक्शन चाहिए, तो इट विल बी रैंडम और इट विल बी बेस्ड ऑन पॉलिसी। तो जो एक्सटर्नल ग्रीडी अप्रोच है उससे चलेंगे, तो 20% रैंडम एक्शन डिसाइड करेंगे और रिमेनिंग परसेंट वो टेबल को यूटिलाइज करेंगे। तो ये सब इनिशियली होता है, जब तक वो टेबल स्टेबल नहीं हो जाता। एक बार टेबल स्टेबल हो गया तो रैंडम रिएक्शन नहीं लेंगे, तो टेबल नहीं। उसके बाद अभी अपने पास स्टेट है, एक्शन है, तो नेक्स्ट स्टेट मिलेगी बाय यूजिंग दैट टेबल। सिमिलरली स्टेट है, एक्शन है, तो रिवॉर्ड मिलेगा। तो अभी स्टेट की एक्शन थी तो आपको नेक्स्ट स्टेट मिल गई, आपको रिवॉर्ड मिल गया। बेस्ड ऑन दैट फोर थिंग, ये जो की वैल्यू थे अभी स्टेट एक्शन पेज की, ये अपन अपडेट करेंगे बाय यूजिंग वेरिएबल इक्वेशन। और अभी जो नेक्स्ट स्टेट थी वो बन जाएगी करंट स्टेट, इसको मैं रिपीट दूंगा, फिर आगे आगे ये चलता रहेगा। तो एवरी और एवरी स्टेट एंड एवरी एक्शन की वैल्यू चेंज होगी। तो ऐसा एक एपिसोड में बहुत बार होगा, ऐसे बहुत सारे एपिसोड होने वाले हैं, तो अल्टीमेटली यूटीएल ऑप्टिमल हो जाएगा। अगर आपने इनिशियली अगर 4 ही एपिसोड रन किए हैं, तो मतलब कोई ना कोई परफॉर्मेंस मैट्रिक्स लेते हैं, अगर उसकी वैल्यू चेक करेंगे सेटिस्फाइड नहीं है तो फिर और अपन नंबर ऑफ एपिसोड बढ़ाएंगे, तो बढ़ाते बढ़ाते जाएंगे, तो एक बाय यूजिंग ट्रायल एंड एरर एक ऑप्टिमल वैल्यू। तो अभी ये एल्गोरिथम रन हो गया, तो इस बार अभी वो एल्गोरिथम अप्लाई किया, तो दिस इज अपडेटेड टेबल आफ्टर 5000 इटरेशन। तो ये पहले सारे ही जीरो थे, तो यहाँ पे अभी कुछ वैल्यू आ गई है। तो ये 0 to 100 के बीच में, लेकिन ऐसा कुछ जरूरी नहीं है, वो वैरी हो सकती है। तो आपने रिवॉर्ड कैसे दिया है अकॉर्डिंगली ये वैरी होगी। लेकिन अगर आप ये स्टेट में हो तो कौन से एक्शन परफॉर्म करोगे, 0 1 2 3, दैट विल बी टोटली बेस्ड ऑन दीज वैल्यू। अब यहाँ पे दो सेम वैल्यू है, उसको रिजॉल्व करने के लिए आपको ऐसा लॉजिक लिखना पड़ेगा। तो यहाँ पे जो लॉजिक है उसमें ये, अगर सेम की वैल्यू है इसका मतलब है कि दोनों ही एक्शन का सिमिलर वेटेज है, तो ये कोड के अकॉर्डिंग फर्स्ट एक्शन ही परफॉर्म। तो अपना ये जो क्यू लर्निंग है उसमें ये क्यू टेबल ही लर्न करना था, वो लर्न हो गया है। अब ये प्रॉपरली लर्न हुआ कि नहीं हुआ वो चेक करते हैं। तो एक एग्जांपल लेते हैं, तो इसने ये प्रिंट किया है, आई होप कि आपको दिख रहा है, 2 2
Right on top.
3 2 2 3, then double 2 3 2 0। इसका इंटरप्रिटेशन क्या है कि ये स्टेट नंबर 0 1 2 3 4 5 6 7 एंड 8 है। तो ये टू का मतलब है कि अगर इफ यू आर इन स्टेट नंबर 0 तो आपको सेकंड एक्शन परफॉर्म करनी है। तो यहाँ पे है कौन सी सेकंड एक्शन क्या है, 0 1 2, तो सेकंड का मतलब है राइट में जाना, इससे राइट में जाओ। तो आप कौन से स्टेट में आ जाओगे, ये 1 में आ जाओगे, ठीक है। तो ये स्टेट नंबर 1 है, तो 1 में भी क्या लिखा है, 2, तो 2 का मतलब है राइट में जाना, तो यहाँ पे राइट में चलेंगे। नाउ यू आर इन स्टेट नंबर, सॉरी थोड़ा गलत हो गया।
नहीं नहीं ठीक है। यस यस यस।
आप 1 में हो,
नहीं नहीं जीरो में ही बराबर है।
0 में हो और आपने क्यू परफॉर्म किया,
राइट।
तो आप
वन,
1 में चले
हाँ
गए।
1 में यू गो
1
टू
में राइट परफॉर्म किया तो आप 3 में चले गए। नाउ यू आर इन
स्टेट नंबर 2।
स्टेट नंबर 2, तो यहाँ पे है, तो यहाँ पे लिखा है 3, तो 3 का मतलब है डाउन, तो यहाँ से यहाँ चलेंगे। नाउ यू आर इन स्टेट नंबर 5, तो 0 1 2 3 4 एंड 5, तो स्टेट नंबर 5 में तो क्या एक्शन परफॉर्म करेंगे? 3, तो फिर से डाउन। तो ये शॉर्टेस्ट पाथ है। दूसरा भी शॉर्टेस्ट पाथ हो सकता है, दिस इज वन ऑफ द शॉर्टेस्ट पाथ। तो जो ऐसे ऑप्टिमाइजेशन के प्रॉब्लम होते हैं वहाँ पे अपन ये यूज कर सकते हैं। तो अल्टीमेटली जाके मतलब जो भी आपका रोबोट है, ठीक है, तो वो जिस स्टेट में है और ये जो गोल स्टेट है उसका वो ऑप्टिमल पाथ डिसाइड कर लेगा बेस्ड ऑन पॉलिसी। इससे हुआ क्या, जो रोबोट है उसके पास एक पॉलिसी आ गई, तो अगर ये स्टेट में है तो लेफ्ट जाना है राइट जाना है, वो पॉलिसी से देखेगा। पॉलिसी से देखेगा मतलब वो क्यू टेबल से देखेगा। तो यूजिंग दैट क्यू टेबल वो नेवी शॉर्टेज पाथ ढूंढ सकता है उस पर्टिकुलर प्रॉब्लम की। आई होप कि आपको समझ में आ जाए।
3 से भी राइट राइट।
हो सकता है, दिस इज वन ऑफ द शॉर्टेज पाथ। मैंने आपको बोला था कि जो ये वैल्यू सेम थी, इसका मतलब क्या है, दो की वैल्यू सेम मतलब दोनों साइड से सेम ही है। मतलब ये रास्ते से जाओ तो भी 5 किलोमीटर, ये रास्ते से जाओ तो भी 5 किलोमीटर, दोनों में से एक तो देयर कैन बी मोर देन वन शॉर्टेज पाथ। ये एक शॉर्टेज पाथ। अगर ये शॉर्टेज पाथ सपोज नहीं होता तो आपको क्या करना पड़ता है, नंबर ऑफ रिसोर्स कितने बढ़ाने पड़ते हैं, मतलब वो लॉस कर देता है, क्योंकि कहीं ना कहीं प्रोबेबिलिटी इन्वॉल्व है। अगेन दिस इज अप्रोक्सीमेशन ऑपरेटर। मतलब कुछ ऐसे प्रॉब्लम है जहाँ पे परफेक्ट आंसर नहीं मिलेगा, लेकिन अप्रोक्सीमेट आंसर मिल जाए। तो ये लॉजिक को अलग अलग जगहों पे अप्लाई कर सकते हैं। तो हम लोगों ने इसको स्टॉक मार्केट पे अप्लाई किया था, तो वहाँ पे बाय सेल होल्ड तीन एक्शन स्टेट को रिप्रेजेंट करने के अलग अलग लॉजिक हो सकते हैं। तो जो भी ट्रेडिशनल अप्रोच है उससे उसमें बेटर करता है।
We can open.
वो तो डिपेंड है कि दैट इज टोटली डिपेंड ऑन यू कि आप इसको स्टेट स्पेस को रिप्रेजेंट कैसे करते हो। इट कैन बी फाइनाइट स्टेट और इट कैन बी इनफाइनाइट स्टेट। चार स्टेट हो सकती है, दो ही हो सकती है। वो प्रॉब्लम को मॉडल कैसे करते हो उसके ऊपर बेस्ड है। ऐसा कोई हार्ड एंड फास्ट रूल नहीं है। हमने एक वर्क किया था उसमें इनफाइनाइट स्टेट थी, कंटिन्यूअस स्टेट स्पेस था। दूसरे में उसको रिस्ट्रिक्ट किया था, नंबर ऑफ स्टेट वाज 9 ओनली। इसका को नहीं किया ओनली वन स्टेट। हां ओनली वन स्टेट। सिमिलरली मल्टीपल स्टॉकिंग मतलब जो पोर्टफोलियो मैनेजमेंट करने के लिए भी सिमिलरली मतलब कर सकते हैं, वो स्टेट का रिप्रेजेंटेशन और एक्शन का रिप्रेजेंटेशन थोड़ा अलग है।
नाही व्हॉट्सॲपवर पाठवलं होतं. तुम्हाला हे दुसरं दाखवायचं आहे का? नाही कोड. So so what is happening is you can go down. 3 is down. Hmm. ये एपिसोड खत्म हो गया. So no no. So episode is basically if you start from state 0, 1, 2, 5, 8. नहीं नहीं दिस इज बेसिकली इफ आई एम इन स्टेट 6 तो मुझे सेकंड लेना है दैट इज राइट. हाँ हाँ. तो so so what is happening is that there is something called as this diffusion model. So in diffusion models, what is typically done is that you may have so I'll share this link with also you. You may have so these are all handwritten characters. So you may have the initial character where you start introducing the Gaussian noise. Okay? So you start introducing Gaussian noise, and then you get something that is completely can say so this is completely messed up in the sense that you can't figure out what is that. Okay. So this is a very random thing. The sense that everything is, looks like a noise. Okay, but this noise was introduced systematically. So Gaussian noise was introduced into the image, and then you got here. Now this diffusion models, what they do is that they take from here and they systematically try to remove the noise so that you can reach it. Okay, so these are all again states, and you go from one state to another state. Okay, you can go down now, go down, go down. So if you see, so these are all states where you have gone from x0 state, which was your original picture, to completely chaotic state, which is your last state, x state. And the goal is to reverse this process. So you come from this state to this state to this state to this state. So uh, this image processing technique is basically a mixture of predicting the next model using neural network and using the reinforcement learning for training that neural network weight. So it is a mixture of two things, and this is used for trying to anti-blur the images. Only that, if you go up, go up. So this is basically the images which are generated by DALI. DALI, I think everyone knows, right? Do you know what is DALI? Okay, DALI is an AI-based image generation engine. थोड़ा सा ऊपर जाओ. So, so this is models which are these are not real images. In the sense that these are not clicked images. These are all images which are generated by the image engine which is called as DAL-E, which is basically by the same company with OpenAI. So ChatGPT and DAL-E. So this is like ChatGPT gives you answers, so this gives you images. Okay, so go down, and these images can be taken from the prompt. So you can say that I want a image of a soup, so it will generate an image of the soup. Okay, go down, go, हाँ, so go down. So again, come थोड़ा सा ऊपर. So uh, थोड़ा सा नीचे जाओ. So these are again all generated images. These are not real images. These are all generated by AI. Go down, go down, go down, go down. So if you see, these diffusion models are basically now taking the next step based not on the reward function, but based on the noise that has been introduced. ओके, तो अभी रिवॉर्ड फंक्शन का जो हमारा ये फिक्स्ड था कि every reward function was a discrete fixed value like 100, 80, 60, and then there was a gamma damping factor. Instead, it is having a random noise which is introduced. Okay, and can I expand this, go down slightly. These images. नहीं, थोड़ा खाली कर, थोड़ा खाली कर, खाली 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 खाली, हाँ हे एक्सपांड करा. So if you see, the diffusion models are trained by finding the reverse Markov transitions from HT2 that maximize the likelihood of training data. So it is a mixture of two things. One is deep learning and another is reinforcement learning. So that we can't go into the mathematics of that, but ultimately reinforcement learning directly cannot be used for image processing, because we can't have a stepwise thing to process images. But it has been used in other ways. Like there are millions of uh, text associated with images. So you have image and below that there is a description of that image. So what these people have done is that they have taken this text and images, and then they have done this reinforcement learning to find out the cosine distance between the text and an image. And now you have this transitions to do dal e, where you give a description and you can generate an image. So you can go down, go down, go down, go down further, go down, go down. हाँ एक मिनट थोड़ा सा और हाँ एक मिनट थोड़ा सा खाली 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 समरी में गो डाउन. So if you see the summary of this model, the diffusion model is a parameterized Markov chain. Again, Markov chain means that we go from step 1 to step 2 to step 3. But now you can't go from step 1 to step 5. You always go one step at a time. So that's the chain. Okay. And so that is labeled from x1 to x3. And you can only go from one step to another. And the transitions are Gaussian. So instead of you having fixed values, that you will earn a reward of this from going from step one. So that is now random, and that you have certain characteristics of that random variable. And after that, go down. Uh, so the training objective is to maximize the likelihood of the training data, and you tune the parameters such that so this tuning of the parameters is basically done by deep learning method. And okay, go down. So a discrete, so I don't know what this means, but somehow you basically decode the pixel values. Okay. And this can be done using pytorch. You can go down. So using the pytorch you can create such diffusion models. Go down. And so you can create some random noise and then come back. So I think you can go down, down, down. So here is an example that is, so they have created, so they have given a random image, randomized image, and from there you can generate the final image. Okay, and this essentially is used in DAL E2, so which is an image generation engine. Go down, go down. हाँ एक थोड़ा सा और हाँ हाँ click this. So this is now being used to generate images, music, videos. एक मिनिट झालं आलं खाली जा थोडं. एक मिनिट थोडं वर जा, थोडं वर जा, थोडं अजून 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 थोडं वर जा, थोडं वर जा, अजून थोडं वर जा, थोडं वर जा. So this is the prompt that was given. Give me an image of a bowl of soup that is a portal to another dimension as digital art. This this was the text which was given, and these are the images that have been generated by DALI. You can show the images now. Go down now. Go down. So you see that. Uh, so you this was the prompt: a corgi playing a flame throwing trumpet. Corgi playing a flame throwing trumpet. So this is the image that is getting generated. So these are all. This is basically a neural network. But this training has happened using the principles of reinforcement learning. So the weights of these neural networks have been trained based on reinforcement. So these two techniques have been combined to get uh, text to image transition. Go down. So I will share this link. You can look at this video also how doll E actually works. And these are all images which are go down. So you can see that this is an image, a teddy bear riding a skateboard in Times Square. थोडासा खाली जाऊन अजून थोडासा खाली बस थांबा. So you see that such images, it looks very real. That looks like there, and that is, I don't know if you have. There is a recent even Modi has said that the deep fake. These are called as deep fake. So deep fake are now a menace to the society because this can be generated by everyone, right? So just one more. You can go down and show more images. हाँ hello. बराबर ठीक है. So go down slightly. एक एक मिनिट थोडंसं वर जा. हे येत नाही आहे काय? It should have been there. हाँ मोबाईल नाही on. Okay ठीक आहे. So I think I will share these links with you. You can go through this. And so this is the latest in the sense that DAL E2 is the latest, and DAL E3 is currently preview only, so not available for general public, but it will come to general public in few days. And you can generate videos, images. People are making cartoon films, 5 minute, 10-minute cartoons in just 2 hours nowadays. So that is happening. And so again, it is all conditional probability going from one state to another state. So same thing, Markov models are working. And in image, I found that reinforcement learning is useful for this deepfake. So they are being used there, but not for other things that typically you use for image processing. So you can look at the how deepfake, DALI and other image generation techniques are using reinforcement learning. And so we'll stop here. Uh, any questions? Chat GPT, have you experienced Chat GPT? So DALI is also from them. Can also try it out. Yes. So now a lot of such like with Chat GPT, there are multiple rivals which have come up like Bard and Llama and others. So with DALI also there are many other image processing which have come. So it's a fairly we can say something that we have never imagined. Those things are happening. and they are happening at a rapid pace. And I don't know, like whether we will be able to believe or not believe after few years what is happening. It's very difficult because even if image and videos are shown, Abhi, that recently, as yesterday, I saw that. Uh, so, translation is now happening online. In the sense that Chat GPT can translate to multiple languages. So already it can translate to Japanese, German, to many of the European languages. It can translate automatically. So it has a lot of translator jobs. Like my friends who are working in Pune as translators, they have lost their jobs because five, six people's jobs can be done by one person. Now only proofreading is required. You don't have to actually translate. Translation is done automatically. But yesterday I saw a video where the you can choose a language and it will translate into that language the images. The like the person who was speaking like movie, it was a movie clip. Instead of English, you can do Spanish, you can do Hindi, and not only that, it is talking Hindi. The lip movement is also matched with Hindi words, so it is not just dubbed; it is along with the lip movement, and that happens on the fly. So your movie images are seen on the fly, so that you are actually look. It looks like a Hindi movie which was shot. So that is how the technology is moving at that rapid pace. So tomorrow, if you get a video, you will not know that this video is actually belongs to the person. It might be modified by such DALI kind of a system. So DALI just generates images, but there are many rivals which are coming which can do video modification on the fly. So you will not be able to trust. So trust is questionable. Like what will you trust? You see a news clip, will you trust that news clip? Right? So that is all that is happening, and this is happening at such a rapid pace that will not be able to uh, in a, before we can comprehend, things have already happened, and before we can imagine. So that is how things are. All our students are copying from ChatGPT, and all second years, nahi, assignments, programming assignments, you put that, you find second largest element in an array, code आ जाता है. They submit that code. So it is like that. Yes. So even for English, like they have to write an essay. You put that in ChatGPT, write an essay and use it. I have said that to my students. कि second year में ChatGPT is better than you. By the time you final year में ChatGPT will be better than you in final year. आपको job कौन देगा? Right? It is improving by leaps and bounds every year, every time, every month. You're seeing better and better. अभी Gemini, which has been released by Google 2 3 days back. So there are this uh, test cases for programming also. So there is a prompt what is given and the code that is given, and you basically test how much of that code is valid. So Chat GPT does accuracy is 16 to 18%, whereas Gemini is around 40%. So already from, so Chat GPT is just 1 year old. So before 1 year, zero. Today it is 40. It has gone to by every month we are seeing improvement. So in 2 3 years, you'll see that programming would be English. So you say in English and you will get a program. So that is what we are envisioning, especially in regular routine kind of programs. That is what going to be happen in next 3 years. Like we are creating websites and other things. You just tell ChatGPT create a site, back end is Node.js, front end is JavaScript, उसमें ऐसा form होना चाहिए. You write description in English, it gives you the code. Front end का code, back end का code, everything is done. It will be password protected. It will have a link for forget password. Everything is done. It generates the code, entire code. Though the token size is 2048 now, it will generate the code till 2048 characters and 2048 words, and then it will stop. But if you take the licensed version, then it is there is no token limit. तो हम लोग तो अभी फ्री कर रहे हैं, कर सकते हैं, यानी फ्री कर रहे हैं, but things are moving at a very very rapid pace. And this DAL-E uh, is something that is going to blur the boundaries between things. And so, what we can trust, what we cannot trust, is going to be questioned. So, image processing is going to be very very different 3 years down the line. Very different. Anyway, let's stop here. So, yeah. So I think we are done. Huh? Thank you, sir. So, sir, we are done. So,
Now we'll be having the article discussion. So group one, Gurujar sir will share his slide. I will take your next discussion. सर आप आर्टिकल डिस्कशन करते हैं.
seven.
ग्रुप वन में है आप? पार्टिसिपेंट्स यही बहुत कम, स्ट्रेंथ भी बहुत कम। ग्रुप सेवन में है क्या कोई?